So thank you for joining us again. Welcome back. I hope you enjoyed your lunch. I know it's sometimes quite difficult to drag yourself into a conference room after lunch, but you should be now well fed, a little bit watered, and ready to have some very intellectually engaging content. So with that, I have my great pleasure to welcome to the stage Professor Dirk Schoenmaker. He is one of the professors that if you've ever looked for a textbook on sustainable finance, he's the author. So all of our team, we have several copies of your books, just to specify, and we always recommend them for people who don't want to pay thousands of euros in courses. Just read his book, and then you pretty much have the basis covered. So it's a great honor to have you on our advisory board, and also for you to join us here in Prague in person. So over to you. Thank you.
Thanks a lot, Linda. And great to have you all here. And of course, this is a difficult spot. After lunch, the others are already going to sleep. And my job is to keep you awake. But let me test. How many of you are trained as an economist? And how many as a macroeconomist? Okay, quite a few. But all of you know the business cycle. Hey, what happens there? And that's exactly what happens with sustainability. When we got the Green Deal, we were at the high end. We got more than we expected at the time. And now we are at the low end. And the word which was a bit missing this morning is long-term. Sustainability is about the long term. The issues don't go away. And in the long term, I'm also part-time at the pension fund. The Japanese pension fund was mentioned. In the long term, all the transitions play out, and then you have the stranded assets, and you have the front runners, which then become business as usual. So if you take the long term, then there is no way out, and I think Jean this morning said it quite clearly. The train has left the station and is not returning. So in that sense, it is here to stay. And the second issue which we discussed this morning was a lot of the Draghi report. And I'm really sorry to say it because I'm a big admirer of Draghi. He saved the euro. But he didn't include sustainability. If he would have written a report about competitiveness in the long term, then sustainability will just be part of it. So I personally don't see any conflict, but just if we think long term, then sustainability can be a risk and can be an opportunity. I did a lot of work on companies, and I thought what's nice, because Linda is running this great platform in Central and Eastern Europe, to compare countries on their performance. Because we talk a lot about companies, but let's turn to countries. It's a new paper. I'm going to publish it with Bruegel, and I already presented here. This is the second time. And what I will start is the ID, then a very small model, so don't worry. Then some examples. I apply it to the energy transition. And then, of course, the big thing is, what are the policy implications? What can governments do to speed up transition? And, well, the idea is quite simple. We face sustainability challenges, both environmental and social. And as we often do, we start with the environmental, but I think quite a few mentioned this morning the social aspect. Transition can only happen when we include people in regions, so we need a just transition. I don't have time to spend on that today, but it's crucial to recognize, because we talk about society. But I give an example on the energy. And there's a huge difference, not only across companies, but also across countries. And the very simple question we ask in this paper is, which part of the profit or loss account of the country, GDP, is at risk when a transition would happen? I do today energy, You could do it for biodiversity, circular economy, which is a bit further way out. You can do it for social transition. If we are not allowed to breach human rights or have to pay living wage also in East Asia when we have our clothing made, all these kind of transitions you can do with this model. So which part of a country GDP is at risk if and when a transition happens? And it fits in a broader research. We have the global drivers with trade going not the right direction. After the global financial crisis, David Eckman of the Bank of England on financial vulnerabilities, putting GDP at risk. And our research is doing the next thing, just transition. If that happens, what can happen? Which part of GDP can disappear? Like a country can go bankrupt, like Kodak, who didn't see the transition to digital photography and then bankrupted. And the same, of course, countries don't go bankrupt, but countries can lose their GDP if they are too late in signing up for the new world. And bear with me, because some of you are really specialists. The purpose of this research is to have top-down, to have a first view what are big differences between countries. Of course, if you want to know more, you have to drill down with micro-research. So this is really, we call it a bird's eye view. You are above the forest, and then you check out where the drought is and where the new leaves are growing. That's the purpose, to have the first order differences. And now, with a small risk, but I will keep it short, because the results are more interesting, the model. And I'm happy there are quite a few bankers in the audience, because the bankers know the expected credit losses, and this is exactly the same model. Hull, the famous book on derivatives, and I see the bankers nodding. So this very simple model of expected credit losses, we just translated only the words. Instead of credit, we have now transition. So your GDP at transition risk is your exposure at transition, the probability transition happens, and then finally, what is your loss? Remember, with lending, if you have collateral, not everything is lost. So if you have good collateral, you regain, you don't have full loss. But now my job is to translate these three terms to transition. So exposure, probability, and then loss given transition. That are the three items. And just to remember, sector K is we have the full economy, and then you have certain amount of sectors. K is 1, 2, 3, which add up. And I just use the Eurostat high-level sector classification. So, what we say, the exposure or transition, it's only 2 steps. And this is the last equation. Exposure or transition is the weight of each sector times GDP, so it adds up to 1, and you have the full GDP. And then, for example, I do energy transition, so the sectors are the high carbon sectors. That can be 10, 20, or 50% of GDP. So B stands for, in our case, the high carbon sectors of the economy. I'll show you in a minute which sectors are included. And then, as I said, it can go to 0 to 1. The next thing is, how well are you adapted? Or in a simple word, how well are you prepared for the transition? And if you are extremely well prepared, the transition happens and you survive because you were a front runner, you can easily step into the new economy. So then your adaptability is 1, so you're fully prepared. And if you look at the equation, 1 minus 1 is 0, so your loss given transition is 0. So whatever happens, you had like full collateral, as the bankers would say, full good quality collateral, so being well prepared. If you're not prepared at all, then it happens, and you are a stranded asset. So your adaptability is 0. You can live in the old world, but not in the new world. Okay, that's the model. Then you see straight away, we have 2 elements which are central. The first one is the B, so how big is the sector? And I assume the transition happens, so the probability of transition is 1. So given that transition happens, what GDP is at risk? So we have the sectors, the structure of your economy, and secondly, your transition preparedness. And of course, after the results, I would talk about what can a country do on either of the 2. What can they do in structural adjustments? Hey, you know, the European Commission always loves structural policies. And what can you do on at the preparedness of sectors? Okay, so let's go in. We are now in the empirics, energy transition, because we have good data on carbon emissions. So step 1 is, which sectors are the high carbon sectors in our economy? And high carbon we measure as the amount of emissions. And yes, it is only scope 1 or 2, that's a pity, because the aggregate Eurostat data does not have scope 3. And you divide it by gross value added, and that's a difficult word for GDP. That's the way Eurostat is using the data. So the amount of emissions for each euro, I was almost saying dollar, but it is Eurostat, each euro of sales. EU27, Eurostat, and what we find is these are the high carbon sectors, electricity as you expect, transport, mining, agriculture, manufacturing, water supply, construction is not that high. And then all other sectors like education, business services, like law firms, consultants, and so on, they have extremely low emissions. So basically, the agriculture and the industrial sectors we classify as high carbon sectors, and the remaining services is low carbon. So we look only at the high carbon part of your economy that is at risk. That's step 1. Now the adaptability. So you remember it was between 0 and 1. So we take the baseline exactly in the middle. And then we say, if you really have already low emissions in your sectors, you're quite well prepared. You have new technologies. So in the end, if your emissions going to 0 in high carbon sectors, then you are fully prepared. A is 1, no losses. The other way around, if you have very high intensity, high emissions, then in the end, you're completely unprepared. And then your A is 0 and your full losses. The full amount is lost. Okay. I'm a bit at risk. I will split the graph in 2 in a minute because then it's more informative. I just want to show you that at the high end, GDP at transition risk, Poland, Bulgaria, the home country here is number 4. But Poland and Bulgaria are really high. And at the other end, France and Sweden being extremely low. So that's, and a lot of countries in between. But I will split West and Central Europe, because then you can see it a little bit better. So first of all, it is a huge range, from 8 to 43%. That's huge, so there's a big difference. Low risk, and I don't dare to say it because people hate policies, but the high carbon tax in Sweden is working extremely well. Because remember, the first country with an IPO of an electric vehicle maker is Volvo with Polestar. So because of the high carbon taxes, they were earlier in getting away from high carbon. France with nuclear, of course, that helps. You can debate whether you like nuclear or not. There are other risks, but for carbon emissions it helps. And the two very coal-based economies, and I'm happy to hear today that there's movement happening in Poland at the moment, so that's good to know. These are 2023 data. So if you have a coal-based economy, you will end up very high. But there are also surprises. Denmark, any of you who is doing ESG rating stuff, the Nordics, because that includes Finland, always end up top, always. But why is Denmark not ending top? Okay, let's yeah? Okay, agriculture. Yeah, the agriculture and... Okay, I think that's partly true, because I'm Dutch, so I know everything about agriculture, but there's still some other sector I will reveal in a second. Sorry? Yeah, exactly, shipping. So, and you only find out by doing this type of analysis. On the other side, the Central European economies are not at the forefront, but Slovenia is really at the lower end. And for you, that's no surprise. You know the country very well. So you find some interesting differences. So I made 3 groupings. First of all, we have like Luxembourg, Malta, Cyprus. They don't have much industry, service-oriented, and not interesting for the energy transition to investigate further. So we exclude these 3 countries. Then we have Western Europe, Central and Eastern Europe, and then the carbon intensity, you see it is twice. You remember carbon intensity divided by gross value added, twice as carbon intensive as in, so twice as less adapted for the future. And now I show it by detail. So here we have the West, and exactly, so Greece and Denmark, you know, Greece is the home of almost all shipping companies except for one, that's Maersk in Denmark. So you see the 2 shipping countries, and then all the others, and France and Sweden ending up as one of the best. I will go in more detail in a minute. Now, the area of today, I will go out of the way, you can make the picture. The slides will be made available. And so what's happening here? So first of all, Poland and Bulgaria are clearly behind. Slovenia, I already mentioned, is a real front runner. And so if you look at these numbers, a lot are in the middle. We need to do a little bit more to say a little bit more. So what we do is we drill down to the biggest sectors. And yes, agriculture is a huge issue in Denmark and in the Netherlands, but still the sector is quite minor as part of GDP, probably 5% or less. But manufacturing, power generation, and transport are the 3 big sectors which are high carbon. So let's see what's happening. And I take a bit of your patience, because you see many graphs, don't try to read them. I will explain them. So if you're positive, you are more adapted, so you have less GDP at risk. If it is negative, you have more at risk. So for example, Belgium and Austria are in manufacturing behind. The Nordics are in the front, and Germany is in the middle. I had expected slightly less, but Germany is in the middle. If you look at electricity, then it's quite clear. France and Sweden up front with low emissions. And Germany, which is also coal-based, we know that. So these are the ones behind. Germany in the middle. France at the front. And Germany. So this is happening at manufacturing and electricity. So we see the front runners and the laggards. So the energy mix of power generation really makes a big difference. I can explain the difference in results. So if we look at long-term competitiveness, it's quite clear there is a deviation between the countries, if you look in the long term. So how quickly can Germany convert, or will they stay behind? And then what was from Erste Bank, you mentioned it, shipping. So, and that's really nicely coming out of these numbers. So I asked the questions after I got the results. And this way, you can see what's happening in your economy. Quickly going to the same picture for Eastern Europe. So, again, you see Slovenia is quite high on manufacturing, so they are more advanced there. Czechia is doing quite well in the upper middle. But Poland and Bulgaria are really behind, so their technology, the carbon intensity of manufacturing is quite high. And of course, in the electricity mix, they are really at the bottom. So that's what you really get out of in manufacturing and power generation. That's where Poland and Bulgaria, if they want to prevent GDP losses in the future, they have to work on that. And we heard this morning quite a few things on transition finance. So also for the banks, for the investment funds, these are the things where you can make a difference if you help out the transformation of manufacturing and electricity. On transport, I don't have a particular clarification why Lithuania is doing worse than the rest. So now we move to policy, the last 4 minutes for me. So you can do two things: decarbonize and change the structure of your economy. And I want to keep on stressing that point. Carbon taxes are not going to do the job on its own, but don't forget we need a carbon tax. And for all economists in the room, the carbon the cross-border adjustment mechanisms, trade economists hate it, but we need it for an effective policy. So if Denmark would take things on improving shipping efficiency, the motors and bio-based fuel for shipping motors, the only thing we can do is, if ships who don't do that anchor in European harbors, we need to have a charge for that. Otherwise, you cannot implement these policies in international markets. And we proved with carbon tax, with the cross-border adjustment mechanism, we can do that. So, and secondly, Darren Acemoglu, the Nobel Prize winners with others, Philip Akion, the smart strategy is you tax high carbon, you get some money in, and you subsidize the transition, because we should not forget, and I don't have to tell you because you are more practitioner than I am, we need to help the sector to make the transition possible. We cannot just expect it overnight. The market is not going to do it. So we need the financial institutions, we need government policy to allow companies to convert from high to low carbon. So we really need the R&D, and we need to work with companies, but in a faithful way, not just lobbying to keep the old structure in place, what is 9 out of 10 times happening, but really to move to the new world. And then, reality is, like I'm from the Netherlands, we were a big shipping nation. So what happened in the 80s? We were subsidizing all these big shipping companies, only delaying the sector for 10 years, at billions of cost for the government. And yes, of course, shipping is now happening in Korea. So you only delay transition. You cannot exempt that, and like the same with textile. All of Europe is now happening somewhere else. So just protecting industry and jobs, that's not future-proof on the long term. That's the main message. Still, governments are always doing that. Here we have a big discussion in the Netherlands on steel, fertilizer, and we all want to keep these basic industries, but some of them will have to go to other regions, like to Spain, where energy is cheaper and more available. So we need to... And then the Danish model is really great. You don't protect jobs, but you protect people. So you give them a social security payment, you give them retraining, and then in a proper way, so you make them ready for the next job. And that's called flex security, retraining with keeping more or less your salary, or 70 or 80% of it with social security. That's extremely important for Europe, because we don't want to leave regions and people behind. If we do a hard market-led transition, we all know that outside of the capital cities like Prague and Warsaw, where the nice areas and the new industry is, you have the remote areas, you kill the industry, no jobs, and that's a recipe for bad news. So you really need to take care that if you do this, you do it together with the regions and make sure they get new type of industries or convert the existing industry. That's crucial and often forgotten. And research from earlier research shows very clear labor reallocations or structural policies is critical for, and let's be self-critical. If, for example, if you look at Germany, they were great in mechanical engineering, but they have great technology in university, many of them, but they lost the transfer to mechanical to electric engineering. They lost that one to the UK and the US. And also physical infrastructure, so you really need to change, including I'm from academia, so in time you also, and like in finance, I'm a big fan of sustainable finance because that's the future. Still, 90% of our colleagues are still teaching neoclassical finance, which is something of the past. Because if we don't change the governance from shareholders to a stakeholder approach, which is for Europeans quite normal, but we are still working with American textbooks with only shareholders existing. And that's why I spent a lot of my time on writing new textbooks, because we need a new way of thinking. And then we can do it. I don't know whether it's time for questions, but no, we get a very... one question. And by the way, my latest book is called Corporate Finance for Long-Term Value, because I really think the word sustainable is, there was already 3 years ago, as out of fashion, and it is about the long term. It is all about long-term valuation. One question.
One question for the brave person. Yes, please, Andreas.
You already mentioned that this was the macro, but from looking at the charts, the micro is quite obvious. So yeah. Austria manufacturing is probably one big company responsible for 10% of greenhouse gases, and Slovenia manufacturing is a lot of pharmaceuticals, which high value add, low CO2. Have you already, visibly you have thought in those directions already, or is there another paper coming?
Thanks for asking that question, Andreas, because what we have done with this new book, Corporate Finance for Long-Term Value, we do social and environmental value with shadow prices and then discounting it with the social discount rate. So you have the financial value of a company, social and environmental. And we did it for AEX, that's the Dutch companies. Next year, I need my students because there are so many companies, 400 master students. Next year, we will do the DAX, Germany. My colleague is working with Italy. And I should work with Linda to do the Central Eastern European companies, because that gives... Exactly. And we should do that because it gives such a huge insight. And in our case, it is ArcelorMittal, steel, but also alcohol. Alcohol is huge. Social, hospital, traffic accidents. Each Sunday morning you hear on the radio so many accidents because of... And so that was also doing quite negatively. So you can really see what's happening in the economy. And then 8 out of the 23 companies were driving the results, and 3 in particular. Yeah. So the bottom-up looking at companies is extremely powerful to see what's happening. Thanks.
Thank you very much, Dirk. That was fantastic. So, I think that's actually a very good question to end up on, because I do think that we often overlook the critically important companies and the segments that can actually determine the future of an economy. In our countries across the sea, there's definitely some national champions with outsized impact. So next up, we actually have Professor Doyne Farmer. How we actually managed to invite him, we're very excited. So we read the book, we saw it on the FT shortlist of best economics books of the year. And then we thought, well, we're just going to reach out and invite him, and he probably will never answer. Not only did he answer very quickly and said, yes, I would love to come to Prague, that's okay. So we're extremely happy and very honored to have you here. And Dirk's book actually looks at something that's super interesting for us. It's how to navigate complexity and how to build better economies and economics for the future. So thank you, and please, Doyne, join me on the stage, and the floor is yours.
So I'm very happy to be here. Let's see if this is working. No, we're going backwards. Let me go forwards. Oh, there we go. It's pushing the wrong button. Okay, so as you said, I have a book. I'd love it if you read it. There are free copies here, which is wonderful from my point of view. I tried to make this book a story. It's about, I have a rather unusual career, and so I tell the story of my career and of the movements that I participated in, including chaos and complex systems, and now complexity economics, and in particular focusing on the green transition. This is what's in the book. I talk about a variety of things, from financial markets to the analogy between ecology and economy, what causes business cycles, but I have a focus on the energy transition, and that's what I'm going to talk about today. To be honest, we need better guidance for the energy transition. If you look back at the economic models that we've had, the answers have been terrible. Nordhaus got a Nobel Prize for saying that the optimal temperature, initially he said, was 5.5 degrees Celsius. It's crazy. And it sort of persists to this day. In particular, the integrated assessment models and the models made by the IEA, all for decades dramatically underestimated renewables. They underestimated their deployment, they overestimated their cost, and not just by a little bit, by orders of magnitude. And so I'm to talk about how to do this better. Oops, I keep pushing the wrong button. So I'm going to begin by boasting. My track record is better than theirs. And in fact, in 2010, I published a paper in Nature saying something that at the time was considered outrageous, which was that by 2020, solar would be as cheap as coal-fired electricity for generating electricity. And as you can see from this quote from The Economist, they viewed that as wacky, but actually we pretty much hit the nail on the head. And now I'll show you how I made that forecast, because it wasn't rocket science. And I want to begin with a little discussion about the history of energy over the last 140 years, which my postdoc Rupert Way compiled. On the left, we have costs of energy, and on the right, we have the deployment of energy. And let me begin by just talking about cost. Here we see coal. It's bouncing up and down over, again, 140 years. On one hand, you can see the price is volatile, but on the other hand, you see that if you draw a trend line through it, it's almost flat. Once you adjust for inflation, coal costs now what it did 140 years ago. Similarly, for oil or natural gas, there's slight shifts, but roughly speaking, they cost the same as they did 140 years ago. In contrast, look at solar energy up here. Solar energy is now 1/10,000th the price it was when it was first deployed in the Vanguard satellite in 1958. And how did I make that forecast? Well, first I plotted the data in log scale. I should have said this at the beginning. This scale is in powers of 10. And in powers of 10, exponential change looks like a straight line. So I took my ruler, I plotted the data, I drew my line, I projected out to 2020, and I said, okay. And that was right. In contrast, these fancy models that the IA makes, the models that all the integrated assessment people, the IPCC runs, these are all based on optimization and all kinds of assumptions that turn out to be wrong. So how can we do something more reliable? I'll come back and talk about deployment in a minute. So first of all, this is an example of the kind of methods, and somehow this got dropped in the projection. Okay, sorry. But here is the price of solar, and what you should have seen, and somehow it got dropped now, is that starting with a point where you make your forecast, you see a fan of probabilities coming out that allow us to forecast not just a point forecast of what will happen, but what are the range of outcomes. In other words, we forecast how accurate our forecast is. Because if somebody can't tell you how good their forecast is, you should ignore it, in my opinion. So you really we focused very hard on making forecasts with error bars attached to them. And I'm sorry this slide didn't project. Now, an updated forecast for the present, and by the way, let me actually go back and say one more thing about this plot. If you were able to see the fan, you'd see there's a fan about like this, and that this was when the forecast was made. The data since then has stayed well within the boundaries of the errors that we suggested, which has been the case across the board for these kind of forecasts. This is our forecast for what's going to happen now. We took solar and wind and we disaggregated them into their pieces. And we saw that for wind, the balance of system cost has not changed over the last 2 decades. This may be because windmills, in order to reduce costs, they've gotten bigger and bigger and bigger and harder to install. In contrast, for solar energy, to our extreme surprise, modules and balance of system costs have gone down at the same rate, which is about 12% per year. And this has happened for 30 or 40 years. And so we forecast that that's going to keep going. And in fact, by 2050, which you can't even see in this plot, solar energy will be at about $3 a megawatt hour. That is, it will be more than a factor of 10 cheaper than it is now and make energy cheaper by far than it's ever been in the past. Now, and by the way, you'll see we also are attaching error bars to this, so it's not guaranteed that it hits that price, but we can forecast the range of outcomes. This is just to illustrate that for all of the key technologies, if you sat in the past and made forecasts going forward, and I should say all of our methods are based on thousands of forecasts made this way to test and see if we'd been in the past with the data that was available then without knowing anything about the future, would we have gotten the answer right? And so here you see the error bounds for the 95% confidence levels, and you see that about 1 time in 20, as you expect, you stay inside those error bounds, and the forecasts for key technologies like solar, wind, batteries, P2X electrolyzers have been pretty good, though for P2X electrolyzers, the uncertainties are large because we have very little data at this point, and they have further to go. Now, what about rates of deployment? So let's go to this side of this picture here. And okay, up here you see traditional biomass, you see coal, again, remember these are powers of 10. You see oil and gas coming up till they roughly match coal around 1970. And then you look at solar and batteries and wind and P2X electrolyzers, and what stands out is the exponential rate of increase, which is very rapid for all of these technologies. And so once again, we've been working hard. This is actually a much harder problem to make these forecasts, but I just want to show you a little bit of history in more detail. So we're blowing up the picture for solar and wind. Solar has increased over the last 4 decades at roughly 30% per year. Wind has increased at roughly 20% per year. And if you project these forward, you see that within 13 years, solar would take over the energy system if it just holds this rate for another 13 years. Now, that's probably not going to happen. It's got to, let me just make sure I emphasize this point. Once again, in this kind of plot, exponential growth is a straight line, and you see solar wiggles around that line, but it roughly adheres to that pattern so far. Now, technologies, we've now collected data on 100 different technologies. And I should have said, actually, with our cost forecast, those were based on data for 60 technologies. We collect lots of technologies. We come up with a way of forecasting technologies in general and then apply it to solar and wind so that we have a lot of statistical significance in what we're doing. Technologies, their deployment follows what's called an S-curve. It starts out slow, it accelerates, and then it flattens off. But actually, again, if you look in logarithmic terms, then you see that it follows something much simpler. It's exponential growth that eventually levels out. And I left this formula just so you could see the exponential growth part in here. So all the way up till about here, you're just experiencing exponential growth, and then that exponential growth declines. So we've developed methods for forecasting this, but let me just say the part you can forecast with the most certainty is if you have a prior about where the S-curve is going to level off, how fast are you likely to get there? And when we just try and forecast that, we make quite accurate forecasts. So depending on your prior about solar energy, if this is the IEA net zero target of 6.1 terawatts of capacity, we'll be there in less than 10 years, 9 years, which is faster than the IEA says we'll get there. They always make the error on that side. If you ask, when will solar energy dominate the energy system? Well, roughly by 2050. So, in other words, that's assuming that you think it's going to get that far. But if you say, is it going to generate 40 terawatts, it gets to 40 terawatts before 2050. Now, and what does this mean for the energy transition? Well, we've done an analysis where we put the technologies together. We assume we have a mixture of solar and wind and all the existing hydro nuclear. And we compared phasing out fossil fuels fairly quickly in 25 years. Actually, we did this a while ago, so it would have been 28 years at the time. So we compare a fast transition to a slow transition to a no transition. And we use our forecasting methods using, actually, according to us, the fast transition is business as usual in the sense that it's the most likely by quite a bit from history. And we see that the fast transition is very, very likely cheaper at any reasonable discount rate. The expected savings is around 12 trillion, although that's an uncertain number, and it depends, that's with a 2% discount rate. But we also see that we need to be worried about a disorderly transition. The ride is likely to be bumpy, and we need to think about navigating carefully in order to get there. Now, let me just say we also analyze nuclear. A nuclear transition, that is where we build conventional nuclear reactors, which, by the way, have not gone down in cost since they were first deployed in UK in 1956. In the US, they're about 3 times as expensive. In Korea, they're maybe not quite 3 times, but they certainly have not gone down in cost much at all. It's 35 trillion as a result more expensive than business as usual. And by the way, I want to go back to the other slide and just say one more thing about this. This expected savings, where does it come from? Because we really worked hard to put all the systems costs in there. The cost of building out a bigger grid, the cost of building pipelines to ship ammonia around and replace oil pipelines. So we put in all those costs. We tried to be extremely conservative in the way we did it. The reason there's still an expected savings is because the faster we do this, the sooner we drop the costs, and the sooner we realize the savings from the new technology. In contrast, in a nuclear scenario, that doesn't happen. And I've been meaning to write a paper on SMRs for the last couple of years, but too many other things keep intervening. But let me just say that I'm quite convinced they're not going to be cost effective. Anybody who wants to make a bet, my personal view is it's 100 to 1 or less, that they will be cost competitive. The uncertainty is huge. Scaling laws make the starting point very high. There's a reason they build nuclear reactors big. That comes from just area volume ratios. Learning by doing could never catch up because the other technologies are moving down the learning curve while SMRs are doing it. So I think it's a waste of investment. Of course, I don't mean to say, I want to strongly echo all the things Dirk said in the last talk. I'm not arguing that, this means we don't need to do anything, the market's going to take care of it all. Not at all. I think it just means we have the wind at our back. We can let the market help us rather than having to fight the market the whole time. We need to really work on energy storage because we have to do that to get that last 20%. We need to dramatically expand the grids. We need to fight against fossil fuel misinformation. One of my hopes is that as green energy gets bigger, it will acquire more political power and it will have more ability to lobby and parry the fossil fuel industry. So I think we'll get there, but the battle is far from over. Now, when will fossil fuels decline? This is a topic that's much discussed. To think about this, you can't just look at how many fossil fuels we're using. That's like trying to study the stars when the sun is out. You have to really look at what the competitors are doing and the process of technological change and replacement that we've looked at many, many examples. And what happens, first of all, you have to remember that transitions are fundamentally exponential. Technologies move up exponentially and then they level off, as I showed you a moment ago. Energy use increases at 2% per year, which is why fossil fuels keep going up, because in absolute terms, even though solar energy is increasing at 30% per year, if you ask what fraction of the energy system is that increased, it's still a little less than that 2% per year growth. So fossil fuels are still growing. But we're just about to see that change. And exponential growth at a 30% per year rate, where 2% is frankly negligible, is small until it suddenly gets big, because exponential growth goes along slowly and then it shoots up. And we're just about to see that shoot up happening because solar, in terms of primary energy is at about 1% now, but it's at about 4% in terms of useful energy, which is what counts. And now we're going to see, and so once this starts happening, fossil fuels will decline exponentially. Now, and because the rate of change also grows exponentially with solar. So every year, you're going to see in absolute terms an exponentially larger replacement. Now, how to go beyond just using history? Because history's great, but we want to think about alternative futures. We want to think about scenarios. And so to do that, I want to say something about agent-based modeling, which is the approach to economics that we've adopted. We create digital twins of the economy, or pieces of the economy, and we simulate the economy by using agents who model things realistically. We use heuristics. We try and get inside the heads of the people who are making the decisions to understand what decisions they will make without assuming they're rational. And we model the world from the bottom up. So if we're modeling the whole economy, we simulate millions of households with heterogeneous demographics. We simulate tens of thousands of firms and the decisions those firms will make. And in particular, and we employ what I call the concept of verisimilitude. We try and simulate the economy as it is rather than as if it were something else. We formed a company called Macrocosm to scale up the methods that we've been developing now for a couple of decades, reduce them to practice, make predictions day in and day out, be able to supply the answers that businesses need to make this transition, because I want to reinforce Dirk in saying we need to show businesses how to make the transition and how to make it profitably and sustainably. Now, our modeling philosophy is, first of all, pay attention to history. I hope I've shown that we've done that. Try and predict what will actually happen. rather than, and then nudge it, rather than, the traditional approach is to say, well, if we want to reach this climate target, and if we had a global beneficial dictator who could do everything we needed, then what would be the least cost way to get there? That's not the way things happen. And consequently, those models aren't testable, as well as making unrealistic assumptions from the beginning. We make testable predictions, we test everything extensively, and we try and understand how good those predictions are so we can build models we can count on. We're building a digital twin of the energy system. It simulates energy markets, finds prices and quantities sold, and therefore we can estimate the profits of all the companies in the energy market. We're doing this at literal one-to-one scale, meaning the initial conditions in the model are energy companies that you know because we will simulate all of them. We ask how much will each company invest and which assets will they invest in. This is the part where we have to get inside the head of the decision makers at the company. We have to understand how do they compute returns on investments, how do they compare investments, how do they make decisions. But the good news is that we have a database with 150,000 assets, 30,000 energy firms covering 25 years. So we have the order of 75,000 decisions to test the model on to get there. And this is a global policy laboratory because it means we can put in policies and say, given a country has this policy, what's likely to happen? Now I'm going to try and show you a demo, although sometimes I have a hard time running this demo. So this is, first of all, how did the Canadian energy system evolve since 1971 or wherever we started? And you can see they're adding hydro plants, they're adding gas plants, coal plants, nuclear reactors, and so, and you can see roughly where it's going. Our model is simulating things at this kind of resolution and trying to match this kind of historical data. So, for example, in the first one, oh no, sorry. I have this problem. How do I need to click. See, problem is there's a little bar down there that I should be able to click on, but I can't with just this clicker. Well, okay. Actually, no, you're seeing, you may have seen that one happen there. Oh yeah, now we're seeing this one happen. So we can simulate with and without a carbon tax, and we can make predictions about which technologies will be deployed, what the technology balance will be, and most importantly, which companies will make what level of profits. Now, let me see. So our goal by 2025 is to extend this for the globe and for all industries. So far, we've done it for Canada and the US. Do for economic planning what Google Maps did for traffic planning, meaning we create a map of the economic and financial systems with information about all the companies, all of their suppliers and clients in it, and we can simulate them and their environment to see what strategies lead to what outcomes in terms of both profits and sustainability. And I think this goal can be achieved in 10 years if we can just create the investment. On that note, let me just end with a sketch of the model we're building. The energy investment model I talked about is here. We have a micro model here. I didn't have time, a labor market model to deal with the stranded labor problems that Dirk mentioned. Policy feasibility models where we actually do LLM on climate treaties to understand which policies are adaptable by which country at a given point in time, and technology cost forecasting that I talked about. So anyway, on that note, I believe I have about 8.5 minutes left, and I'm hoping for good questions from you guys. Thank you.
Hello, my name is Maria Lendelova. I work for Schneider Electric, sustainability business, so topic very close to my heart. I have a question on all of the costs and the prediction of the solars and the wind especially. Do you also include operating costs and especially end of the year and end of the cycle kind of costs in that?
Yes, we work quite hard to make all those costs in there. Now, I encourage anybody here to go look through what we've done and see if you think we've done it right. If we haven't, we'll figure out how to do it better. But we did go to great pains to get those things right.
And maybe a little bit follow-up on that. How do you see the end of the life when it comes to solar and wind and the technology behind it to be taken on board in the next 10 to 15 years when we compare to some kind of the traditional power sources? What do you think is more developed?
When you say end of life, I don't quite know what you mean.
So we are also facing other elements when it comes to the carbon intensity. So we see a lot of the solar panels. So when it's the end of the life cycle, where are they going? Are they going to the landfills? Are they going to be reused? The same with wind. Is this cost that sometimes should be borne by the producer, sometimes should be borne by the customer? Is that accounted?
Well, I think mostly we should be able to recycle. I mean, solar and wind it's not like plastic bags, right? You know where they are. The materials can be recycled, and I think we're going to see a largely circular economy in that direction. You know, steel is already like 95% recycled. So, and there's an amazing, just to say one other thing that blew my mind, the Eastman company, so Dirk mentioned Eastman Kodak that went out of business for tracking the wrong technology. They now have a plant in Tennessee that cost them $500 million to build. They can take low-grade waste, reduce it to molecular form, and recycle it, making biodegradable plastics. And they're making already 20 million a year. So, and they're planning to do it for the whole United States and then the whole world. So I really think we're going to see a transition to a much more circular economy.
Thanks very much, Hugh Whelan, financial journalist. Great presentation, thank you. I wondered in your learning from history part there, whether we can learn from history about displacing an industry which is so lucrative and so prevalent as fossil fuels and so linked into geopolitics, whether there are lessons to be learned there from the past about that. And second question, storability of energy. What does that mean for the take-up of solar and wind, actually, and renewable technologies?
Sure. The first question, I mean, I've done some reading. I can't claim to be a real expert on the history, but when you start reading about the history of any technology, say take railroads, well, railroads were competing against canals, and when we look at those time series, canals are shooting up on their S-curve, they get close to the top, and then railroads start coming in, and canals get displaced. So technologies compete against each other. It's highly political. Railroads involved a lot of politics, corruption, huge incentives. It was a very complicated thing, and there was a lot of pushback because of right of eminent domain, and I think we can learn a lot. I mean, maybe part of what we learn is we're going to have to live with a lot of crap, but I do think these things work out in the wash. And I forgot to say this, but when we've actually modeled S-curves, so we have 100 different technologies ranging from railroads to mobile phones to whatever, what we see is that deterministic rules capture about 80 or 85% of the variance. In other words, most of the story is deterministic. There's the bumps in the road, the Donald Trumps, the Chinas. So there's all these events that are perturbing things, but the surprising thing is most of it is about the technology and where the technology goes, and it seems that, and again, I'm not saying these other things aren't important. Wait, but you asked me about that and storage. Well, storage, please, Dirk.
Shipping was very big, textile. With subsidies and with the power of industry, we delayed the transition for 5-10 years, but in the end they died. So I think it's only the dying of the industry will only be delayed a little bit with their power. You cannot avoid it.
Yeah. Now in storage, I mean, that's the key. And, we were maybe more hopeful about hydrogen electrolyzers and ammonia and those kind of fuels 5 years ago than we are now. I think they're going to happen. And because we really, in the model I said, we assumed we were dealing with aviation, shipping, all of the different sectors of the economy, not just electricity. And we assumed that we had enough storage to run the entire global energy system for a month without any input from the sun or the wind. And that may, as it turns out, not even be quite enough. But I think we also, one of the striking things is that even if you have enough gas-fired plants to cover the electrical system, if you're only running them 5 or 10% of the time, and that's typically economical because gas is the dominant cost of running a gas-fired plant, whereas solar's become very cheap. And so therefore, it's going to make sense to be running gas-fired plants only a small fraction of the time and having gas as a backup if we need it. But I think eventually we will be putting hydrogen in caves in case a meteor hits the Earth, and we will be shipping ammonia or other liquid hydrogen-based fuels around the planet, because once we have solar energy at $3 a megawatt hour, it's going to become very cheap to make those fuels.
Okay. My question would be rather abstract. You spoke about complex system modeling, and I'm a physicist by my background, and I'm trying to make sense of the predictions. What I'm interested is whether you can see there are some kind of stable domains where the system kind of stays in a similar state, and then probably a phase shifts or things that we might like understand better or make sense better of the possible dynamics of what we are trying to approach.
Yeah, so it is a form of phase change. I'm a physicist too, by the way, originally. It is a form of phase change, but maybe different than the ones in physics. As Dirk said, in my opinion, how does the economy grow? The economy grows by finding good technologies and switching from one to another, as it did in photography. If you look at chemical technologies, we have many of those in our database, they improve at 1 or 2% per year. Whereas solid state technologies improve at 30 or 40 or 50% per year. And so the economy just hopped from one technology to another. And if you go back through the history of the economy, it does this repeatedly. There are certain functions that have to be performed, like providing energy or structural strength or things like that. And we're changing horses from time to time in how that happens. And the way those transitions work, that's the part that I'm saying is remarkably similar every time. There's always an S-curve where one technology rises up its S-curve and the other one falls down a complementary S-curve where it's flat and then it plunges exponentially.
So if I get it well, you say that the technology is the driver and all the other things like the policy or demand side are rather trailing the technology part.
No, I'm not saying policies don't matter. I mean, the policies, for solar energy to expand by the amount it has in the economy, it had to move from niche to niche to niche. Right? The first use was on a satellite. Then we had use at solar stations. Then it began being used for more and more things. And the niche was such that combined with the incentives that were to push it through the delicate phase, it got where it is now, where it doesn't really need those supports anymore.
Okay, thank you. That was useful insight.
Good, thank you.
I think we have 1 or 2 more questions. There was one at the back and then Marianne. Quickly, we have maybe 3 to 4 minutes left. We're over time again. I mean, you're eating into your coffee break quite literally, so I'm fine.
Well, I don't want to be part of that, so I will be brief, if the questioner is brief.
Hi, super presentation. James Vaccaro. Questions in terms of the replacement of fossil fuels. The assumption in terms of energy growing at 2%. What's the risk of that being disrupted by whether it's AI data centers, whether it's conflict, whether it's rebuilding in terms of resilience, or some unforeseen kind of Jevons paradox type of thing, which kind of means that we never quite catch up. And because I know a wonderful modeling, because the energy investments are done on the basis of profitability rather than cost, what are some of those early insights from the data in terms of which energy companies are looking like they're going to win? Is it those who are currently making the big bets on renewables now?
Yeah.
Sorry, just a second. I'm going to ask for a second question so we can bundle them up. So Marianne, over to you.
Okay, thank you. First of all, I find your approach fascinating, and we started talking about this a little bit last night. My question is, you have an objective by 2035, you want to reach something. And my question is, which technology approach do you think will get you to the final result? You are now betting on this digital twin technology. There are technologies which we did not even think of 10 years ago. We didn't know how tremendously impactful AI is going to be. Now it is. How do you look at similar alternative technologies which might not have evolved enough, but might be by the time you coming to fruition, like for example, quantum simulations, and how do you see these alternatives, and do you plan to do it one after the other, or do it simultaneously to make sure you have a as precise prediction as possible?
Good. Let me first answer the other question. So, okay, I think you're right. data centers, cheaper energy, energy use might start increasing at 3% or 4% or even 5% per year. I think it's quite possible, but that's still a lot less than 30%. And so we have the advantage that these two new technologies are rising, and batteries are also rising at like 50%. I can't remember the number right now, but it's a very big number. So I think the answer is that stuff is second order. And I think if we have solar energy and wind providing our energy, it's maybe okay to have energy use rise, because what's going to be one of the biggest contributors is also going to be the underdeveloped countries developing and going to energy use levels that are comparable to ours. And I think that's a good thing if it can be clean energy, and it will help their lives. Now, back to your question. You also, I guess, asked which companies are going to go. Well, I'm not ready to say that yet. We're in the process of testing our model. We've got the model built and running for Canada and the US. We now have set up our testing pipeline, and we're going to test the hell out of this and we are not going to be making predictions like that in public until we have some confidence that they're right. But to your question, I mean, right now, in terms of running our own models, we can run these models with conventional computing. 30,000 companies is not a very big number, actually. 150,000 assets is not a big number. We believe we could even simulate 8 billion people on the planet with conventional cloud computing, and every company on the planet, which is the order of 100 million companies. That would start to get hard, but it's feasible. But back to your question about which technologies, you said, oh, well, we couldn't foresee AI. Well, I had a group doing AI in the 1980s. And I already knew in the 1970s that this was roughly going to happen. Hans Moravec made a prediction that turned out to be just about right using Moore's law, which is the best example of why these things work so well. Moore made a prediction in 1965 that solid-state devices would double in density every 2 years, and it's been on track until now. We knew that now we would start to fall off of that because we would reach the quantum scale. It laid out amazingly well. And so, and Hans Moravec just said, okay, where do we get to the point where the human brain, where we have as many devices as we have synapses in the brain? And he said, about 2025. And he did this in 1989. So I think the message has been clear for a long time. Now, quantum computing, to me, it looks positive, but one of the things I just submitted a grant 2 days ago to get money for is to really look at quantum computing and fusion and other things like that carefully, because even before they become commercial, you can see how fast is the research progressing. And there are almost always scaling laws for metrics. In the case of quantum computing, it's coherence and number of qubits. And both of those have made good progress. I want to look at more carefully to make better quantitative forecasts, but my gut feeling is that the answer is going to be good. And so it will happen, and I don't think I have to tell you it's going to change everything and make the kind of thing we do easier.
Thank you very much.
Thank you.
Thank you so much. I think that was a proper conversation with the audience. So thank you for those who asked questions. I do find Professor Farmer's work absolutely amazing. So for those lucky ones who managed to grab a book, of course, you can chase him around the block and ask for his signature. Maybe he'll sign it for you. We have a few more copies, so if you would like one, just ask me, and we can arrange one for you. But thank you so much for coming to Prague. So now, last but not least, Dr. Florian Berg. He's flown from MIT, landed yesterday. Looked quite fresh, but then did try to have an early night. So I don't know how many of you have read about the aggregate confusion and all the kind of mess with ESG ratings. So actually that term was coined by Florian, and his research has been covered very widely in different types of media, etc. So thank you so much for joining us in person, and over to you.
Thank you. Hi. So today I want to talk a little bit about being more honest in sustainable finance, what sustainable finance can actually achieve. But maybe partially it would sound a little bit negative, but in the end I will end on a hopeful part. But first let me ask, what does the term ESG evoke when you think about it? What do you think of? A letter soup, absolutely. What else? Reporting, absolutely. What should it do, ESG? Improvement of environment, social and governance? Or?
Society, long-term profits.
Okay, society and long-term profits. What else? Economical and sustainable thinking, yes. So, that's what you said, right? Higher returns, less risk because of better risk management, changing the world, improving the world, respecting values. A lot of values-based funds are in ESG categories, or just organizing topics, right? E, S, and G, environmental, social, and governance. Great term for that. But all those together, they're hard to combine. They're often contradictory. Because if you want to maximize return, then it's hard to optimize for another thing, such as improving the world. And it's just business as usual, right? So I call this the original sin of ESG, that everyone, or literally everyone, when you ask someone about ESG, will come up with a different definition. But let me go a little bit back before, I want you to talk a little bit about sustainable finance and all the institutions that are actually operating in sustainable finance and how they define ESG and where the problems are. But let me go a little bit back and tell you a little bit about the story about ESG. In particular about sustainable reporting, ESG reporting, right? Before in the 80s, before the 2000s, way before the 2000s, companies wrote ethical reports. They were 2 pages long, and it was about the right thing to do, right? And it sort of it was general statements that pertained to everything. That became then corporate citizenship reports, where still you hear this ethical notion, right? Or corporate social responsibility. It's a responsibility, a social responsibility. And then in the 2000s, it started a little bit earlier, but in 2000 it was very marked by that we started actually talking more and more about ethics and financial value, this combination. And this is very much where we are today, right? We talk about finance. ESG is often very much linked with financial returns, but also ethics. And Andreas Rasche and Van Bommel called it the crowding out of morality. And I thought that was a very accurate description of what happened in the sustainability reporting. And also the reports are now much longer. I've seen reports of 180 pages. And there was a little bit in 2004, the term ESG was then coined. And the IFC, the UN Global Compact, and the Swiss government invited a couple of large financial players to Switzerland, and they had a discussion and deliberation, and they wrote a report that initially I think there were roughly 12 big financial players, but 4 refused to be on the report in the end. And they wrote that it's about topics, ESG topics, that have a material impact on financial value. But they also said it will contribute to the sustainable development of the planet, so improving the planet. And this was actually a good thing in some ways, because focusing on financial values meant that we were able to narrow down the topics to focusing on what's actually really what we call material. And this is where actually GRI was born out of this thinking, right? GRI focuses now on 32 topics, but yet it's more impact focused. And then you have SASB or ISSB, which is financial materiality, and that narrows down the topics even more. often to 6, 7, 8 topics per company within an industry. So there was certainly a huge advantage of focusing on financial value. It also, when you think about those ESG topics in terms of financial value, that reduces the cognitive distance, right, between those topics. So that means it makes trade-offs possible. The problem here is that you can then ask yourself the question, how many women do I have to put on the board in order to pollute 1 million tons of CO2 more? A sort of weird thing to frame it, right? Yet, but if it was only about financial value and not about ethics, then we could be totally okay with it. There's no reason to disagree with that statement. But we don't, because we think it's also about more than just financial return. But now we looked at sustainability reporting, let's look a little bit about ethical investing or ESG investing nowadays. It started most of the academic papers talk about the Quakers in 1758 as the first start of the ESG or ethical movement, ethical finance movement. And they stopped trading or participating in slave labor trades, 1758. And that was clearly, no one actually argued that this will actually create higher profits or increase return. That's very clear about that. But it was the right thing to do. So they did it. Same with the divestment campaigns in the 80s, 90s for fossil fuels, right? Everyone knew they have huge cash flows. So it was because it was the right thing to do, and we forego some return. Then it became social responsible investment, and then ESG investing, and now it became about we maximize return, but we also have impact in some ways. And you can actually see that even the discussion about the divestment in fossil fuels also changed. It's now about stranded assets. Yet, the assets are not stranded. Hopefully soon, but not yet. Those companies, those fossil fuel companies, continue to generate huge cash flows. So, before I keep going and walk you now through sustainable finance and the actors in the sustainable finance space, and where you see these contradictions, I want to step a little bit back and talk a little bit about something more theoretical. There's a huge difference, there's a huge confusion in the space between investor impact and firm-level impact. Just because I own a stock of a company that emits low CO2 emissions and I buy that stock does not mean that anything in the world changes. It just means that the company that I own, or part of it, emits low CO2 emissions. As an example, if you are the ESG investor and you buy that stock, you might actually drive up the price, right? So that would mean that the company has easier access to financing, lower cost of capital, as we say, and then could do more good, more whatever it sells, with lower CO2 emissions than comparable companies. The problem is now when the price goes up, me as a traditional investor, if the markets are very liquid, and stock markets are very liquid, then I would just immediately see, oh wow, my dividend ratio is actually really bad. I sell the stock, the price goes back, and there's a rotation now happening. You have the stock, the sustainable stock, I don't anymore, but for the company nothing changes. So there is a difference between firm-level impact and investor impact. And the problem is, if you as an investor want to have real impact, so you want to go beyond the equilibrium, by definition, you drive up the price because you want this company to have easier access to financing, but that also means you will have, if you succeed, you will face lower returns in the future. And so this is then, you have impact, but it has a cost. The other way of having impact would be direct engagement, shareholder proposals, or really as an asset owner going to a company and starting discussions. That also has a cost. In particular, if you succeed in changing the company, if not, it would just be business as usual. And you see that when you look at ESG fund names, they say, some of those funds say, we look at ESG factors, but we want to maximize returns. So why do they speak about ESG? Because in a subtle way, it tells you, it suggests you that you will have impact, right? You do something good. But imagine if you apply that same to a growth fund. You would never say, oh, I buy this growth fund because I really believe in GPUs, and so I want NVIDIA to have a lower cost of capital so they can deploy more GPUs. No, you say I invest in a growth fund because I want a higher return. So why do we treat ESG differently here? And there's, for example, we did a study about the impact the impact of ESG ratings on mutual fund holdings. That was very interesting and very revealing. We looked at MSCI rating. MSCI ESG ratings, this is what sustainable fund managers use as an input. They say actually that it's about risks and opportunities, financial return. They don't say it's about impact, right? It's clearly about, again, impact and return. And so we looked at all the ESG funds in the US, and Europe is a similar picture. And we looked at what happened to stocks where the ratings goes up and where the ratings goes down. Nothing surprising, the holdings go up and the holdings go down, right? That is not surprising. But the surprising part is actually the timeline. It's expressed in months. It takes the asset managers up to 18 or 24 months to integrate new ESG ratings that supposedly are a source of superior information for higher returns. Why would you wait 18 months? It basically means that those firms, those asset managers, they use it as a compliance. What it also means is we also show then temporally this correlates with a higher market cap when you have an increase in the investment share. So that means a lower cost of capital, means impact. But the MSCI ESG rating never talks about impact. The other thing, when you look at ESG ratings, they are an average. All ESG ratings out there are an average of different topics, sometimes from 35 to up to 282 different topics, weighted average, to create this one ESG rating. But the question is, from a risk perspective, does that actually make sense? No, it doesn't. How can you compensate oil spill risks with DI risks or human rights risk? It does not make any sense. It would make sense from an impact perspective because I have a preference and I can get a little bit of this preference here and a little bit of this preference here, and then I create a portfolio. So they are built from this point of view, actually. And then we have SFDR. Highly criticized, but yet still liked in Europe. It's about to change. It's a sustainable finance disclosure regulation. And here, as a lot of people of you know, as any fund in Europe, you have to declare if you're an Article 6, a traditional fund, an Article 8 fund with ESG characteristics, or an Article 9 fund with a sort of dark green impact. And it says clearly in the first 10 sentences of SFDR that SFDR is here to create impact. They say they want to finance the transition. Yet, when you look at the regulation, there's no direct path towards impact. Article 9 is all about firm-level impact, about firm-level impact. And yet, and even worse, I think, that Article 8, you declare that you follow ESG, but you still maximize returns. How is that different from an Article 6 fund? I'm saying this, I don't say with that ESG information is not important. And I will talk about that in a couple of slides. I'm just saying that why is business as usual a different category? Because it will suggest, in the end, that those funds are different and that they will change something in the world. The problem is, if we're lying to ourselves and we invest in funds that think that change the world, but they actually don't. They just maximize returns and are business of usual with an expanded information set, then this could lead to crowding out of policy. Because I think, oh, the markets will solve it, so why do I have to vote for a party that creates regulation, right? The market will take care of it. That's a big problem. Or to more licensing behavior. I invested in a low CO2 fund. I'm doing everything I can against climate change. Let me take a plane to Paris to buy a new suit or a handbag next week. And this happens. Those effects or this mental accounting exists in us. The other thing is about the ESG backlash. If that's true, and if we always say we want to maximize return, but then we actually we think also sort of that we change the world, then maybe some of what they say is true. The problem is that when Ron DeSantis says ESG is woke, then he doesn't know what ESG means and he doesn't know what woke means. I hope they let me into the yes on Wednesday. And Elon Musk said ESG is just a hate factory, but that's basically because he thinks that mistreating workers should offset his electric vehicles. That's basically, when you look at ESG ratings, that's why he doesn't like ESG, because he has a low rating because of unfair labor practices. But there might be actually some truth to it. So now I would like to make still the case for ESG reporting, like CSRD. I think it's important. And from the firm perspective, it is actually, there might be an advantage to bring companies to measure things, right? Because what gets measured might get managed if they see that there's a mismatch. I have plenty of anecdotes of companies I met where, over the years, where actually the CSO or the CFO told me that they were surprised how bad they were performing in some aspects. And this can reveal it. And then we would close what we call the capability gap after a cost-benefit analysis. But anything going beyond this cost-benefit analysis would obviously have a cost. Why do we need ESG data from an investor perspective? Because it absolutely makes sense. If you wanted, as a VC, you wanted to buy a startup, and 2 months ago they exchanged 8 out of their 10 employees, you would certainly investigate further. When you look at mergers and acquisitions of large companies, they do a due diligence. And they certainly ask about employee turnover, they ask about environmental liabilities, about all sorts of ESG risks. So why are only those allowed to have that information and not smaller investors? So there's certainly a case for ESG reporting for maximizing returns. Yep. And now my last point, I think the most important point. I think everyone cares about impact. I've been to Washington, to Congress quite a couple of times in the last years talking about ESG regulation. And yes, actually, I think it's even more fun to talk to Republicans. Because the Democrats are convinced already, right? It's much more a challenge. And it's interesting, when you talk to them, obviously when I talk about climate change and maybe human rights issues is not their major concern, even though there are Republicans that are very concerned about it. But their major concern is, for example, they really start listening when I talk about, for example, values reflected in your investment regarding abortion. It might not coincide with your values, but certainly theirs. And there's certainly a link to be made in the discussion. And so I do think that everyone actually cares about impact. And so what we need actually in sustainable finance, we need to be more honest about the impact that our investments have and the costs involved. Because there might be actually a case where just some investment has a real tiny, smaller return, but a huge impact for that, right? a telephone company, for example, creating a project for giving out mobile phones to underserved communities, it will be much cheaper and much more impactful for that company than maybe for an NGO, because they're already specialized in it. But it will have a cost. And as an example, is what I have here is that if you have two investments, one with 10% and the other one that gives 10.1% in a year, and you have to watch a little kid working in a gold mine in Africa, and you know that this kid will not survive until 25 years old because it has to manipulate mercury, I think you really have to be a psychopath to invest in to get this 0.1%, right? And so what ESG in the end does in this sense, it is mainly reducing this moral distance between us and our moral campus and our investment. And I think it's time that especially regulation with SFDR, for example, opens up that impact, that people want to have impact, and not everyone wants to 100% maximize their return. Thank you. And now I take questions.
Please, we have one question at the back already, so over there. The microphone's traveling towards you. Anyone else who wants to also ask a question? Okay, one more there. Anyone else? Now I feel like I'm doing an auction. Who's going to pay more? Andras and then Doin, okay.
Thank you so very much. Jindra Chekanova, Jeshimne. My question is about this moral return on investment. I really have been hoping for years now that we start to see the return on investment of investing in nature, clean air, functioning oceans. And yet I don't hear in any of these congresses, seminars, that there's anything other than a purely financial return. So do you see that ever changing? Thank you very much.
Yeah, I think this is what I want to say, right? Some people want value more than financial return. Imagine you're a pensioner and you invest in your pension fund, and then you realize that your pension fund invested in a company that is putting actually lead into your drinking water, and then you have to buy a filter, right? Or it pollutes the river that you like so much and gives you joy every day when you walk next to it. That is also a return, right? And this retiree would be certainly very angry to know that he contributed to that pollution. So I think we should take this more into account, because so far, and I think academia is very guilty of that, we always took this base assumption that everyone wanted to maximize return, which I do not think is true. And academic research got a little bit more open to that in 2017, but before it was always the starting point. And I think this is combined then with legislators. This is still often the starting point of legislation. But this also means we need to be much better at assessing what actually the preferences of people are. And that's complicated.
I think that's also a very interesting point to explore, right? If I have a preference and I really want to make sure that there's no greenwashing and I want to invest in the right way, we actually need that regulation and the data, underlying data for that. Yep. Doin, over to you, and then Andras, if you can pass the mic just behind you, okay?
I guess I just want to make sure I understood the punchline.
Yeah.
And with your last example, I think the lesson I'm taking away is that we need to make sure ESG can be a mechanism for forcing disclosure, so we actually know what the other things the companies we're investing in are doing.
Yeah.
But maybe you're saying more than that? I mean, in that, does ESG help make sure that we can get that information about companies? What does it really change at the end of the day? And because I think you're saying we need to rely on people to do the right thing, and we need to make it clear what trade-off they're actually making when they don't.
Yeah.
But I want to make sure I understand the punchline.
Yeah, that's great. When ESG was created newly, then we didn't have the ESG information. So there was certainly mispricing there, right? Once the information came out, companies and also investors could react to it. The problem is now that we're in a phase where every asset manager has access to ESG information. Everyone buys ESG data. So I don't think that those, or it doesn't look like that those mispricing is still systematic, right? And in that absence, we sort of hit the point where we are not stuck, but where we get into an equilibrium where the cost-benefit analysis is done, right? And if we really want to improve the world, then we need to go beyond the equilibrium, and that has a cost. That's basically what I say, a little bit more in economic terms. Yeah.
Thank you. Andras, quick question from you, and then Astrid, and then we wrap up with Florian.
Okay, my question probably goes in a similar direction as the question before. It seems that you try to bridge three worlds, basically the world of the market forces and financial value, the world of externality, and we can say that stable climate is a positive externality. It doesn't cost anything to add anyone to it.
Yep.
And there is non-real value too. So, and these two are kind of mutually exclusive. And the third world that so far serves to bridge that is the world of hopes and projections that we might get both the externality and also the.
No, I think there's no. That's why I'm saying there's not necessarily hope. I'm saying it's as a cost impact, right? And the externalities, someone has to pay for it. It's either the company or you make the company internalize the externality that has a cost, right? Or you bear it as an investor if you want the company to internalize.
Thank you, question answered.
Sorry?
Thank you, the question was answered.
Okay, thanks.
By that.
Thank you. And Astrid, quick last note. Please introduce yourself.
Astrid Mattei, German Environment Agency, and the former rapporteur of the platform Sustainable Finance. Thank you for the presentation. How would MiFID and IDD fit into your scheme? Because that's exactly what we try to do in Europe, right? We required banks, insurance companies to ask retail investors about their investment preferences regarding sustainability. And to say that it does not work perfectly is an understatement.
Yeah.
Now, things are complicated, and a few of these things are not perfectly designed, but it also suffers from the problem that things are complicated. So if you want to really want to understand people's sustainability preferences, you have to ask them many questions.
Yeah.
Or you ask them just one question. Do you want it to be sustainable? Oh, yes. No cost, same return. And this is why we have the Green Claims Directive now, because we had all these funds that were claiming that they are green, they were not. So we have the directive. Funds are not getting green, funds are renaming.
Yeah.
So how does it fit?
But the thing is, the big problem with the funds in general, no matter what name they have, is that there's a confusion between investor impact and firm level impact. So the way SFTR is built and is that you still can get away with or as an investor you can buy an article, let's say a dark green impact fund, and it says even impact in the name. Then maybe the companies will only have impact, but you as an investor, you don't. And when you think that it was suggested that the fact that you buy this fund changes something in the world. I think MiFID is great, and it is very complicated, right? I mean, great, you're laughing. I heard a lot of examples, for example, from financial advisors that told their clients, don't say yes about sustainability because if not, we sit here tomorrow. Those things, right? But those are also the beginning. We have to train people to understand what sustainable finance is. But I think here, in particular, we need to be honest that if someone really wants to, because if not, it's just greenwashing or impact washing on a huge scale, right? We need to really be honest about the fact that if you want to have impact and you really want to change something, then you might actually have a cost. And it's complicated. It's very complicated. That's why I think this whole everyone wants to maximize return, that's why we had this assumption, because it's just an easy assumption, right? It makes things so easy, even though they're not true. Yeah.
Thank you very much, Florian. On that note, we will end this session. It raises a good question for you to discuss over coffee break, right? Do we need some sort of unified pricing mechanism so that there is some sort of, we have EU ETS, you can discuss how badly that's working. And also look at all the other systemic failures that we have for pricing the externalities in. Because at the end of the day, who do you think pays for it? You. It's the taxpayer. So sometimes people forget that it's actually your tax money tidying up. So it's a, what do they say? Socializing the cost and privatizing the profit in some ways. So anyway, that's up for discussions, whether we need some sort of tweaking of the system and whether it's done better by market forces or by government. That, of course, depends on your political and ideological leanings. Anyway, on that super positive note, we have lovely coffee and food. There's one change to the program. We do have a delayed speaker traveling from Paris on a train. Very sustainable. But that means that we will start with the discussion first and end up on a presentation. So thank you very much. Off to a coffee break.